All right, number 16 from the Chapter 4 homework. This question reads, 6 years from now, you'll be inheriting $100,000. What is this inheritance worth to you today if you can earn 6.5% interest compounded annually? Okay, this problem changes gears a little bit from the ones that we've done up to this point. We've been given present values and we want to calculate future values off of it. We've been solving for the number of years it will take to grow a present value to a certain future value amount, and we've been solving for the interest rate that we'd have to earn to get from one present value to another future value given a number of years. Here, we're going to solve for present value, and we haven't done that yet. We're given a future value, a discount rate, and then a time period, a number of years. And we've got to take that $100,000 and bring it back to today's dollars. And the concept here is a little different than maybe what you're used to thinking about. Okay, but it's vitally important when we're talking about finance and the time value of money. Okay, so 6 years from now, you're going to get $100,000. Right? Well, how much is that worth to you today is an interesting question because it's not going to be $100,000. Okay, let's simplify a little bit and think about what might be going on. Suppose I offered to give you $1 today, right now, I'll give you $1, or I gave you the other option of I'll give you $1 6 years from now. Which one are you going to take? Right? Of course you're going to take the dollar today. Why would you wait 6 years for $1 when you could have it right now? Okay? So that dollar today is worth more to you than the dollar 6 years from now. So in order to make that deal worth it to you, to make you take the payment 6 years from now, I've got to offer you more than the dollar. I've got to offer you more than what I'm offering right now. Maybe if I offered you $10, $100, maybe I offered you $1,000 6 years from now, or $1 today, well now all of a sudden you might be willing to wait 6 years, right? So you do this naturally, but you don't realize you're doing it. You discount money that you might receive in the future back to today's dollars. And you do it inside your head, you just don't realize that you've done it. All right, so that's what we've got to do here. We're going to take this $100,000 and bring it back to today's dollars and see how much it's worth to us. Okay? But here we're going to discount by 6.5% interest. We're just going to pick an interest rate. Normally we'd use an opportunity cost here, what we could earn on a savings account or something like that. Okay? But we're just given the discount rate in the problem. Okay, and what we're going to use first, we're going to go after it with a formula and algebraically. This is the exact same formula we've been using up until now. We've just rearranged it and solved for present value instead of future value. Okay, normally it's PV times 1 plus r to the t equals future value. We've just divided the 1 plus r to the t over to the right-hand side. So it's future value divided by 1 plus r to the t. So we're discounting the future value to get back to present value. And if you look at our timeline here, it's running in the opposite direction than we have before. We've got time period 0, which is today here, going all the way out 1, 2, 3, 4, 5, 6 years. We're going to get $100,000 at the end of 6 years. And what we want to do is discount that back to today's dollars. Okay, so what's it worth to us today? All right, so we just dump it in the formula. Present value is what we're solving for, equals our future value of $100,000 divided by 1 plus 0.065. That's our discount rate that was given to us in the problem. And then raised to the 6. That's our t. It's going to be 6 years from now. Okay. So in the next line, what I've done is gone ahead and calculated this. That's the, clear out what we've got there. It's the 1.065 y to the x 6. So that raised 1.065 to the 6 equals 1.4591. Okay, and again, here it's not going to hurt you that much if you just write it down and only do the division to 4 decimal places, but I still store it in the calculator. And here's the way I do that. I want to divide $100,000 by 1.4591, or I can do 100,000 times 1 over 1.4591. It's the same thing, right? So what I'll do is I'll make that 1.4591 1 over 1.4591 by pushing the 1 over x key right here. Okay? And then I'll do times 100,000 equals. Okay, so that gives me the 68,533.4119. Okay, so the present value of $100,000 that we're going to receive 6 years from now is $68,533.41. So in today's dollars, that $100,000 is only worth a little over $63,000. I'm sorry, $68,000. Okay, so we would be indifferent now if someone offered us a deal. What this problem is saying is that I'll either give you $68,533.41 today, or I'll give you $100,000 6 years from now. We would say, I don't care. I'm indifferent between those two. Because what we could do is receive that $68,533 today, place it into our bank account, and earn 6.5%, or what was our rate? Yeah, 6.5% interest. And 6 years from now, we'll have that $100,000. So we could do it ourselves, or you can do it for us. It doesn't matter to us. We'll take either one. Okay, now let's get at that with the time value keys. That's using the algebra. So I'm going to clear that out and start the same way we do every time. Second, clear TVM. So it clears out anything we have stored in those time value keys. We'll start with N, which is 6 years. So we type 6 and then N. Our interest rate is 6.5. And again, our calculator is smart. It knows for I over Y that it's an interest rate. So we can do 6.5 instead of 0.065. So do 6.5, press the I over Y key to store it in there. Present value is what we're looking for. You see PV equals a question mark, so we can skip over that. That's what we're going to compute. Payment is 0, just like it is in all these problems. And then future value of 100,000. And it does, whichever way you want to go here, you can make, I've left the future value positive. You can make it negative. If you enter the future value as a positive, you type in 100,000 and then store it in the future value. Press the FV key. And then when you compute, say compute present value, it's going to give you a negative number. If you make that future value negative, it's going to give you a positive future present value. So whichever way you want to go there, it doesn't matter on these problems. Okay, what you find is $68,533.41. Okay, so we get the same thing that we did up here.